So in this video we're going to be looking at the SI base units, which are the units which cover the metric system. Now I've previously said that the metric system can be shortened to the MKS system, standing for meter kilogram second. However, there are more units. The meter kilogram seconds can cover everything in classical mechanics. So most of classical mechanics is done with meters kilogram seconds, so anything to do with motion. We will have to introduce more, and that brings our total up to 7. So they can combine to create every quantity we've discovered, like magnetic field strength, which is represented in Tesla, to the rate of decay of an unstable isotope, which is measured in becquerels or disintegrations per second. So it can be described as a combination of these main units with some other units thrown in. Now these other units include things like radians, steradians, and we've also seen disintegration. So they're just words, essentially, or cycles is another one you'll come across. But we don't need to worry about those for now. So here are the units. I recommend you keep note of these because they're quite important. So the quantity, the unit, and the symbol. You need to make sure you have them all known and in the correct order. So length is measured in meters and is given the symbol M. Mass is in kilograms and is written as kg. Now, we will get onto this, but it's the only one to have a prefix before it. The story of why it's called the kilogram is actually very interesting, and the YouTuber Veritasium made a very detailed video about it, so I recommend you watch that. But mass is measured in kilograms. Time is in seconds, given the unit S. Temperature is measured in Kelvin and is given as K. Now, this is not the same as degrees Kelvin. It is simply Kelvin. So it's 50 Kelvin and not 50 degrees Kelvin. Luminous intensity is measured in candelas. Now, candelas we won't really get onto much. We probably will in the astrophysics chapter 12, but that's quite far away, so we don't really need to worry about candelas for now. But they are one of the 7 main units. Electric current, very important for the entire electricity chapter, is the ampere. And the amount of substance is a mole. Now, we will come across a mole when we get to heat and temperature, the ideal gas law, as well as fluid dynamics when we get to Boyle's law, sort of hidden in that. But much like the candela, we're not going to have to worry about the mole too much. So as I was saying before, the kilogram is the only one to have a prefix in front of it. So you might wonder why it's not the gram, but instead the kilogram. As I said, you could watch the Veritasium video about it. Sometimes quantities we're looking for may be too large or too small. So at one point we could talk about the mass of the electron, which is 9.1 by 10 to the minus 31 kilograms. And in the next minute we could talk about the distance from the Earth to the Sun, which is 1.5 by 10 to the 11 meters. Now, of course, these are different units, so that's one thing to point out. However, their magnitudes are vastly different by a factor of 42-ish. So the people who made the SI units also produce the prefixes, of which you can append to the unit to denote its magnitude. So some common ones here. We have kilo, centi, milli, micro, nano, with their symbols here. And the amount 10 to the 3, 10 to the 2, 10 to the minus 3, 10 to the minus 6, and 10 to the minus 9. However, at this stage, well, obviously we won't be covering it, it goes far down as pico, which is written as p and 10 to the minus 12, and femto is the one after it, and it's 10 to the minus 15. So it keeps going down further and further, but after nano, we pretty much won't be getting onto any of these. So there's no real need to worry.